Everything is chaos, Ned.
Yeah, the news has been hopping.
No, I mean at work. I don't even know how many servers I have.
Have you tried Fathom? It can describe and map your applications to your infrastructure. You can learn more at the break.
Yeah, I think so. For one, when you see a LinkedIn post saying Terraform's dead this year or next, something like that, I think the person who wrote that post hasn't gone out and touched grass in a really long time.
Welcome to Day 2 DevOps, where the DevOps is in the details. I'm Ned Belvent, and I'm joined by my captivating co-host, Kyler Middleton. Hey, Kyler.
Hey, Ned, I'm flattered. Guiding us through the false reports of Terraform's death is our guest, Malcolm Metalka, co-founder at TerraTeam. With no further ado, let's do it.
I have LinkedIn Gold or whatever through the Microsoft MVP program. So they just give it to you if you're an MVP, which is good. I would not pay for it.
Yeah.
Same on all counts.
Yeah. I mean, it does give you some more information, but like honestly, the biggest and best performing posts I've ever had on LinkedIn were not because I was consciously trying to reach on LinkedIn. It was just because I wrote about something that I was really annoyed by. And then other people will be like, yes. That annoys me too.
Yep. It's not exactly posting, but it's like a posting cousin, you know? Like those are the ones that do the best.
But it is kind of interesting too, like for posts like that, you're kind of surprised how many people have that issue too, and it's like not solved. It's one of those things where everyone like feels the pain on their own, and then they like maybe they don't want to admit they have the problem or something like that, or like it's just like it's too small to really like try to do something about, and then you're like, oh yeah, like thousands of people run into the same thing and are annoyed by it.
Yeah, it just takes that one person to put their hand up and be like, this sucks, and I'm not afraid to say it. And everybody else is like, oh my God, thank you. Someone's finally said how terrible this thing is. You know, like Azure's API.
Yeah.
My perennial example, because it still is not better.
The capitalization in the API, right? Is that, were we talking about the same thing?
Oh, no. I'm just talking about like Azure in general. Their API is a nightmare to program against.
Yeah.
If you think AWS's APIs are inconsistent, boy, do I have a challenge for you.
Oh, that's awful.
I was actually looking at integrating against Azure DevOps. Normally you like pass some version information about what version of the API you want to use, right? And like a lot of people just like we do it in the URL string, just /v1 or something like that.
Yeah.
Maybe it's not like perfectly REST or whatever, but it's easy. Azure passes it in through like a query variable on all queries.
Really?
Yeah.
And so just every time you construct the string, you have to add that additional query.
Yeah. It's weird, I think, but it's also like, I don't know, there's something weird about doing like a post with a query string on it, right? You're like, I'm not querying anything. What's this doing to my post?
Yeah. And also, I feel like you really run the risk then of hitting the wrong API by accident because you forgot to tack it on that one time.
Yeah.
Yep.
Yeah, like the other way, you just have like, here's my base API URL. I'll just add everything after that I want. But this is like, no, add it at the end.
I feel like this is a great segue into the general conversation about infrastructure as code because every time I post about IaC on LinkedIn and like whether I'm angry at it or I'm really happy with it, I get lots of comments on it. And also, I think people who complain about IaC don't realize what the IaC vendors are dealing with when they're trying to interact with these APIs.
Yeah. No, I think that's totally accurate. And it's one of those things where even I don't really remember what it was like before IaC. And like you think, like you pull it out of your memory and you're like, oh yeah, like you can even have before cloud, which was 10 times different and worse in certain ways. But then even like AWS comes along and you're like, okay, well I can do APIs and stuff. That's cool. And you're trying to write like a little like Python Boto script to like create your EC2 instances. And you're like, wow, this is really great. And then it breaks and you're like, maybe it wasn't so great. I don't know. I don't really have another option. The OG infrastructure as code was like your Python script trying to call AWS APIs.
I remember writing PowerShell modules to interact with Azure.
Oof.
And that was pretty brutal. And it was before I discovered Terraform. But I really, really didn't want to deal with ARM templates because hand editing JSON is always terrible. And this was no exception to that rule. So I was like, no, I'll write this imperative PowerShell module that will somehow be better than a declarative template. And it wasn't. Well, you've seen it, right? Malcolm, you've seen the post that pronounced that infrastructure as code is dead, right?
Yeah. And it's not just one post. I feel like bi-weekly or semi-weekly, whichever one's twice a week, I can't remember. Somebody comments on Terraform is dead or infrastructure as
Hmm.
code is dead. I actually saw one yesterday that was with AI. It can just do the API calls now, so we don't need this middle layer of Terraform,
Oh, you sweet summer child.
which is unclear to me if that is just like I'm trying to get attention by saying something controversial or actually believing it, and I'm not sure which one's worse.
And that's the bait, right? That's the bait on the internet. Should you engage with this? Because maybe you're feeding the trolls and you don't want to feed the trolls.
Exactly. But also, you don't want someone reading that and being like, "Yeah, that sounds like." You don't want like a junior dev going like, "Oh, really? Okay."
Hmm.
Nobody said they can't do it in this.
Yeah. I want to take some of those at face value, at least for this conversation, that they mean what they say and they're not just trying to put up an incendiary post for the clicks, though I'm sure that's part of it, right?
Yeah.
Well, we were just talking about like writing Bodo scripts or PowerShell modules or whatever. Like IaC, in my mind, was trying to solve that problem. What's like the scope of what IaC was trying to solve in the first place? Because I think we need that before we can say whether or not IaC is dead and something can replace it.
For these sort of things, it's useful to go back to some sort of like definition, right? Like, how do we define IaC,
Hmm.
which, infrastructure as code? Maybe we'll agree on this one, but I think it is defining your infrastructure in a code like representation that follows software design principles.
Yeah, that's general enough that I think we can all agree on it.
Yeah.
And I think, like, to make a distinction there, if you just had a YAML file that mapped directly to like AWS CLI calls and constructed infrastructure that way, I would say that's probably not IaC because IaC generally has more expressiveness than just like the raw parameters of the infrastructure you want to make, right? Like you might want to loop over things or call functions to construct certain things or use outputs of one to the other. So I think you could make an argument that just like a YAML file that's sort of interpreted by something else and does AWS CLI calls or something
Hmm.
might be IaC. But the purposes of this discussion, I think we'll leave that as like sort of a separate thing.
That's an interesting distinction because when I first started working with IaC, it was with CloudFormation. And CloudFormation didn't have looping constructs really.
Hmm.
And it didn't have this sort of interpretive layer. It had very limited like functions you could invoke and barely any to speak of. And I think in the engineer's mind, they envisioned some general purpose programming language creating the CloudFormation template, which would then be fed into CloudFormation. So you weren't really meant to directly edit that file. That was the artifact of some other process.
Yeah, yeah. So we have Terraform now and like other IaC solutions, Terraform, Pulumi. The CDKs are various forms of infrastructure as code. Terraform has one, but then there's like the AWS one as well.
Hmm.
And at least in my head, I think of these as kind of complicated, like macro parsers almost of some kind that are outputting the static construct that we end up feeding into our cloud providers and other services. So kind of like the template you're talking about where something else is generating that cloud formation output. I think it's a similar thing with, how you use Terraform right now.
Yeah. In some cases, that's literally what it like Bicep from Azure or from Microsoft.
Hmm.
That's literally what it does is it takes the Bicep code and it turns it into an ARM template. They call it a transpiler.
Yeah.
Yeah, that's all it's doing is like interpreting what you've expressed and then turning it into a very static ARM template, which is fine because that's what the API is looking for is to be fed these delicious ARM templates.
Yeah, yeah. And to go back to your question, though, what problem is IaC solving? And I think if you go back to this Python Bodo script era or shell scripts, or I don't know what the PowerShell situation was like when you were doing it there, it's very easy to do some API calls to say, create your compute instance or create some sort of storage bucket or something like that. But it becomes quite different when you want to modify what already exists in
Hmm.
some constructed way and you end up doing it yourself until something else comes along like Terraform that actually provides a model for here's how you say what you want and then here's how we go from what exists to what you want. And that's really what IaC is doing. It's providing the tools and the model for how to manage your infrastructure in a structured way such that you can create and modify it as you see fit and get to the correct solution rather than a Boto script that maybe it just makes a new instance because it lost track of the one that it thought it created before or something like that.
Yeah. When I think of it just more generally, the problem that we're trying to solve is we want to manage infrastructure, we want to manage its full life cycle.
Mm-hmm.
And to do that, if I'm just one person, no code, just doing things myself, I need to keep in my head all these variables and like a memory of how things are right now and how I want them to be. And I think what we were trying to solve with IaC is I want to take that administrative load, that cognitive burden, and offload it to this tool and say, hey, you're now in charge of keeping track of how things are and how I want them to be, and then making the changes necessary to bring the world to the way I want it to be.
Yeah. And I think there's another layer too, in that the representation IC is trying to give you is something more human consumable.
Mm.
So you can give names to things, for example. Your resources have names that are meaningful to a human and mean nothing to a computer.
Mm-hmm.
And that is so that you can manage that and understand that in a way that makes sense to you. And you can also structure it in a way that is consumable for a human, and then it turns into something consumable for a machine.
Yeah, it's an abstraction in the same way, your operating system. I don't want to write chipset instructions. I want to have a copy and paste. And that's how I think about it. It's trying to get as human as possible while still being as specific as a programming language.
Yeah. And I think that is where some of the valid discussion points around what the future of IC looks like come from. And I mean, it's kind of interesting to think that IC is kind of the first solution that has gained prominence in trying to make these abstractions more consumable. Terraform, which is still going strong and has tremendous market share. I think we would be naive to think we got it right the first time. So they're probably, when we look at some of these actual serious arguments against IaC, you can see that there actually probably are valid limitations there. And whether or not they are a deal killer for IaC or not going forward is, maybe something we'll try to figure out here. But being the first time you do something, there's definitely some mistakes you're going to make or some things that you're not going to have understood when you started making that.
Yeah. There's that difference between one-way decisions and two-way decisions where one way you've made a decision you can't go back on.
Yeah.
And I think Terraform does have some one-way decisions that, may or may not be the right one. I'm curious, in your mind, because you work with Terraform and OpenTofu a ton, in your mind, what are the major shortcomings and flaws of those solutions?
I think before going into that, I think it's interesting in that I have my own views on what various shortcomings are, but then there's also the people posting around their views and writing blog posts, etc. And I think that what's interesting is what are claimed weaknesses of IaC or the alternatives to IaC generally are considered the strengths within that group. So it's really interesting in that when somebody says, well, IaC doesn't work because of X, Y, and Z. Someone's like, well, actually, X, Y, and Z is why I want to use IaC. And I think that's a really interesting element of it and why I think IaC was probably not going to die anytime soon, because it's not something where a lot of people doing it are begrudgingly using it and they wish they could use the other thing. It's because in many cases, there are trade-offs, of course, but they actually like the decisions made in Terraform or Tofu solution versus using Kubernetes to manage your infrastructure. So given that, some of the discussion points brought up are Terraform. And when I say IaC, I'm going to mostly be speaking of Terraform and Tofu. Pulumi and CDKs are all really the same model, so we can think of them as, variations on the same theme there. Mm-hmm. But they're one directional in that, as we talked about, they're designed for humans to be able to abstract things out and then modify their cloud provider. But if you want to go and modify your cloud provider through another method, it's incredibly hard to bring that change back into your code, because code has an aesthetic and it's a human aesthetic. And it is incredibly hard, even with modern day AI, to automatically turn an existing resource or a modified resource into that aesthetic that you have in your code.
That's definitely something that I have dealt with. And it's a question, when I do Terraform training, that's one of the first questions I'll get is, what if somebody makes a change outside of Terraform? How do I deal with that?
Yeah.
Mm-hmm.
And that leads to a half-hour long discussion, because the answer is it depends.
Right.
Like, did you mean for that change to happen? Well, then, okay, you have to update the code to represent it. Did you not mean for that change to happen? Okay, well, then you want Terraform to reverse it. But if it's a stateful change, you also have to have backed up the previous version and then be able to restore it afterwards.
Someone accidentally hit upgrade on your RDS instance and like, no, 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 we're not ready to go to Postgres 18.
Yes, but if you decide to roll back, that's something that creates data loss. You have to incorporate that into your
Yeah.
operations. And you know what Terraform doesn't deal with? Any of that.
I swear that was a good 2 years of my life of just managing that drift with partial applies where you're managing 100 things and 3 of them have drifted and oh no, we can only apply 2 of them, but I need to make a change in another part of the state, and I'm like, call Kyler, we need to like tear the state apart, and so I hear you that Terraform and a lot of these tools are so powerful and useful and I love them with my whole heart, but it's occasionally an abusive relationship for sure.
Another argument against IaC as we have it today is that it doesn't guarantee that the things consuming it or using it are like those two requirements match up. So, for example, infrastructure is the environment your application runs in. Your environment might need access to an S3 bucket. Well, you can define that S3 bucket in your Terraform code, but did you give it the permissions that your application actually needs? That might be something that you don't find out until you try to access that bucket with your application. So there's a disconnect there that some people think shouldn't be there. And instead, we can perhaps derive the infrastructure from the application or have a tighter coupling there to guarantee the environment the application runs in is always correct.
Yeah, it's true. Terraform doesn't understand the intention behind any of the infrastructure you're standing up, whether that's S3 bucket or a load balancer or security group rules. There's no way for you to express to it and say, this is the app that this infrastructure is meant to support. So please make sure when all this is being set up that the application will actually be able to function. There's no way to express that. It's just, I can say this component's dependent on this one, so they get created in the right order. But that's the long and short of it. It's up to me to understand the intention and the architecture and the app developer I'm working with.
Yeah, and there are frameworks out there that try to solve this. It's generally called infrastructure from code.
I remember that.
There's a few solutions out there. Yeah, I personally am skeptical of that approach for at least for myself. And in particular, I think if you take what has been one of the biggest takeaways of the last 50 years of software development, it's that decoupling things gives you tremendous power because now you have optionality. When you decouple things, you can modify A without B. And that's very useful. So probably one of the biggest examples most people know of is AWS decoupled compute from storage. So if you have an RDS instance and you need it to be beefier CPU wise, you don't have to get a whole new machine and move all your data over to it. You just get a new compute machine and it's bigger and you're done and your data stays where it is. And vice versa, if you just need more data, you can flip out the storage layer there for a larger piece of data and then you can go on your merry way. So that sort of decoupling is really valuable and powerful, I think. And I can certainly understand, well, like I don't want to try to write to my S3 bucket and turn out it fails and similar things. Like there's plenty of things along the way there that are like that. But I think just you're giving up so much by coupling these things that from a software engineering perspective, I personally have trouble getting on board with that counter approach to IaC.
But I'm curious, Kyler, because you work in industry, you have to deal with developers and infrastructure and whatnot. Is that something that your software developers even want to get near defining their own infrastructure?
No, almost always the answer is no. Usually, even in our documentation, it's like when you go to implement this, talk to the DevOps team. And it's not like use the tool, here's the strategy. It's like go talk to the people and it's their job. And so there's for sure this huge disconnect between the application works on my machine and the application works when deployed into the cloud, at scale. And none of the tools that I am personally familiar with solve this in any real way. You need a human, and maybe you need a super powerful AI in the future, or some smart DevOps style folks.
Yeah. I remember the infrastructure from code movement. It felt very short lived, and I can't name a single tool that actually implemented it. So I think that tells you like its level of success.
Yeah, I mean, I think any solutions there are very niche.
hmm
And Just thinking about it, you can certainly do some work to try to make it as so maybe a developer says, well, I want to use a bucket and I'm going to give it a symbolic name for me. And then you can maybe disconnect a bit the actual configuration for that bucket.
Mm-hmm.
But our product being self-hosted is an important element of it. And that means it has to run in sort of any environment. Somebody just wants to get a Docker image and run it and go. So these frameworks would be a negative for us because they just can't represent all of the possible environments we could run in. So there's no value in trying to couple those things. And I think a lot of people have different variations of the same thing. Not only that, you're really tying what your application can do to whatever this framework has done. So if the business goes out of business and you really need some new functionality, it's either, well, hopefully it's open source and you can modify it yourself if you want to, or you're on the priority queue if they're still in business to try to get that added to it. So yeah, I mean, I think like you said, it seems quite short-lived. I don't think I can name a single company either. So
Have you tried Fathom?
Not sure. I mean, I'm really into the MCU and I love Carly Rae Jepsen.
No, not fandom, Ned. Fathom. Their platform helps you discover and map your applications across any infrastructure, on-prem, cloud, or hybrid. They can map your environment in under 60 minutes, building a unified source of truth for your IT ops, development, and cyber teams.
Yeah, but I bet they need an agent deployed on every machine and domain admin privileges. I've got enough agents on my boxes. Thanks.
Surprisingly, no. The discovery is network based and doesn't require an agent or credentials beyond flow records.
Well, I guess then I'm giving my data to another SaaS.
Not at all. Fathom runs on a self hosted system and your data stays inside your organization. Even their AI offerings don't send your data off to Fathom servers.
Well, what kind of AI are we talking about?
They've got Lighthouse AI for anomaly detection and Compass AI for plain English queries. You don't have to be an infrastructure expert to find out what the heck the Dev2 Thanos server is up to.
It is always a good idea to keep an eye on Thanos. Sounds pretty cool. I'll call them. Maybe.
And if this sounds interesting to you, dear listener at home, you can check out Fathom on fathom.com. That's FADDOM.com. You can start free for 14 days, no sales call needed. And they even have a free version.
And I'm going to check out fathom.com right now.
I was imagining this deployment process that you described, where it has to deploy into any infrastructure and you have your sort of self-contained graph of how to deploy your thing. And this concept has come up between Ned and I and our guests, this graph of graphs concept, where a lot of tools solve their own graph. A module solves their own dependency graph of resources. And we don't actually want to solve that as a human. We want to solve the graph of graphs in our business. We have lots of applications and lots of dependencies, and we want something that ties them together. And Terraform does in a small way, but we want to solve it in a bigger way, and that's just not done yet. There's some tools coming that we've seen, but I don't have really a question like this other than, have you seen framing like that outside of, Kyler and Ned's podcast? Or is this something tools will represent in the future where you plug in sort of your dependency and it will map all the dependencies together?
So not phrased in that very eloquent way like you did, but another counter to IaC is that some people view their infrastructure as the management of it is more of a control plane. So rather than the Terraform style where I configure it, I do apply, and then that configuration is static, they want to view it as, well, I have these things happening and my control plane will make decisions. So for example, like an auto scale group or something like that.
Mm-hmm.
So I've actually had multiple people who are very into Kubernetes tell me that the future is 100% Kubernetes. And I think to some degree that matches with at a high level of what you've said, where if you can put yourself into Kubernetes somehow, now you're in part of this whole system and you're not this little thing on the edge, and you can use all the Kubernetes APIs as you see fit. You can integrate against the rest of the Kubernetes ecosystem, and hopefully it lets you be part of a whole in that case.
For me, the biggest stumbling block of Kubernetes as being the management layer is I have to have a Kubernetes first before I can do anything else. And it's like that chicken or the egg kind of problem where what stands up the Kubernetes cluster that manages everything else? And do you want it to manage itself? Like the answer is probably yes.
Yeah.
But I'm basing that off of, I'm going to go old school here and talk about VMware for a second. Buckle up, everybody. It's 2005 again.
You mean Broadcom?
Don't say that dirty word on the podcast.
I'm so sorry. So for the uninitiated who didn't have to deal with VMware, the control plane for VMware was vCenter. And for a long time, the guidance was that you would install vCenter on a physical machine outside of the clusters it was managing. Because what happens if the cluster goes down? How does it bring itself back up? And then the guidance slowly shifted over time that you could, in fact, put the VM running vCenter inside the cluster if you did X, Y, and Z to make sure it would come up appropriately. And you know what? That's what we did, and it worked great. So I guess, maybe I can put that argument to the side. Once you get it all stood up, once you've incepted your first Kubernetes cluster, then you can just put the management of that cluster and other things inside of it and hope for the best. Does that track for everybody?
Yeah, and we're not immune from this in the IaC world. Who manages the bucket that manages your state?
Mm-hmm.
Yep. Who watches the watchers?
Everybody has their own little buckets, and hopefully they're all securing them. And yeah, it's a problem, right?
Yeah, I will say, at least on the scale of managing a bucket for state, that is less scary to me than Kubernetes managing itself. But it's at least the same problem abstractly. But I also think that this goes back to this thing where the claimed weaknesses from one group over the other solution are actually kind of the claimed strengths within that group. So this idea from the Kubernetes world that you want this dynamicism and you want everything's like Kubernetes because it works together. I think if you're really into Terraform, you're like, no, I want to know the things that are static, and I will explicitly construct the things that should be dynamic as being dynamic in my Terraform. And that is how I sleep well at night, knowing certain things will never change and certain things can change. And I feel confident about those things that can change.
Right. I think one of you gave the example of an autoscale group.
Mm-hmm.
I can use Terraform to deploy my autoscale group, but I know by setting certain rules and thresholds that size of that autoscale group is going to change dynamically on demand. But I'm not managing that component of it with my Terraform. I'm just creating the initial configuration or the default settings for that autoscale group and then letting AWS do its thing. I'm totally okay with that. I think Kubernetes, I look at it the same way. I set up the initial conditions and then I can change those conditions if I want through Terraform, but then it's up to the cluster and all the operators to do what they're going to do on top of it.
Mm-hmm.
Yeah. And I think the IaC view of I want this separation of what's dynamic and what's static, to me, that touches me at my heart in the sense that from a software programming perspective, that's also how you construct good, robust programs. You have these cores that are declarative and stateless. And when you call them with the same inputs, you get the same outputs. And then you explicitly say, well, I have a UI, for example, and these things are stateful and they can change. But at least I know where the stateful things are and I know where the stateless things are. And it makes it much easier when you're making certain changes to know, well, this can't change that because I understand that there's a separation here. I think if you are all in on Kubernetes, what Kubernetes can do for you is probably great. But if you're not all in on Kubernetes, having to evaluate in your head what Kubernetes will do given a certain unexpected input is kind of a challenge. And it is similar to this, having state all over your program and not knowing, well, actually, when they click this toggle, this thing all the way over here is going to change. And you didn't actually want that to happen.
Yeah, the biggest advantage of having that automation and that dynamicism inside of Kubernetes is that you can make these broad sweeping changes. And the biggest downfall is that you can make these broad sweeping changes.
Mm-hmm. Yep.
Certainly true of Terraform as well, but at least usually there's a human in the loop. Maybe that's the part that makes us all feel a little itchy. I know I came from an admin and ops background, and Kyler, I think you did too.
Mm-hmm.
Malcolm, were you like an apps and admin, or you come from the software development side of things?
I'm more on the software development side of things.
Us ops people are a little itchy, a little twitchy when things just happen.
Yep. I want to see it. I want to see the code.
Yeah.
I came from network engineering. So you're writing the ACL rules and the object groups and the NAT rules. And that when you just submit your change to Kubernetes and it says, okay, I'll go make all the changes behind the scenes. I'm breaking out in a sweat just thinking about that. It is scary that I hope it works.
I think there's an interesting distinction I've seen where again, the people really into Kubernetes, one of the things that they like is auto reconciliation. It's just always trying to figure out what you have and turn it into the thing that you configured it,
Right.
no matter how that thing happened. But drift detection is like a whole business in the IaC world. There's actually companies that only do drift detection.
Hmm.
And we have drift detection, and one of the options we have is auto reconciliation. So when you see drift, just apply whatever your code is, and 0 people use it. They want to see that plan, and they want to be like, all right, no, that one's okay. I don't know how these two groups are finding their home, whether it's you come up on like an app side or something like that, and you're sort of used to using Kubernetes, and you're like, all right, well, it does the auto reconciliation thing. That's important to me because that's the side I'm on. Or if you come up on more of like a Terraform side, you're really into like, I have a plan file for a reason, and I'm going to use that plan file. And just never the two groups really have experienced each other's situations or something like that. Or when the things Terraform people are terrified of with an auto apply, when they do happen in Kubernetes world, they're just like, it's software, these things happen. Or whether the things that TF folks are afraid of just actually never really happen in reality. I don't know. I think we've sort of, at least in my experience, we've sort of ingrained on these two things. And there's probably room to have some sort of discussion on like, well, how often does this thing actually happen or not happen? But I don't think people are necessarily in a point where they can like have that conversation.
I think the application folks have never locked themselves out of an ASA on the other side of the world. And those sort of fearful, terrible events when the command line freezes and you're like, oh yeah, I'm never going to do this again.
I really like your point, Malcolm, that if you come from a background where there never was a way for drift to happen because it was immediately reconciled by the tools you're using. So the only way to introduce a change is through that tool set and that reconciliation loop. If that's all you ever have, then this idea of drift just seems foreign to you.
Yeah.
Like, how could my infrastructure ever get out of sync? Because the only way changes can ever be introduced is through my code pipeline and uploading a new YAML file. If that's the only way changes happen, great. But like us Terraform folks come from the other end of the spectrum where like we maybe adopted cloud with the portal and running like imperative commands and slowly built our infrastructure that way. And now to like retrofit our processes into this driftless dream just doesn't seem possible.
Yeah. To go back to like, this claim that IC is dead, I think it just can't be true because even if nobody made a new project using IaC starting today, they just had to manage existing products. We still have probably like 2 decades worth of legacy code that it would take to flip out into whatever the new model is. So even if we all collectively agree that this is not the way forward, we still have to be able to understand it and manage it for a long period of time. Now, I don't think that's actually the case. I think many people choose to use IaC because they think it's the better choice. But there's a lot of it. I think what Terraform has something like 70% market share or something like ridiculous when you look at how people manage their infrastructure.
Yeah. Yeah. The last time I looked, Firefly actually has a state of infrastructure report they put out every year. And if you combine Tofu and Terraform, it was over 70%.
Yeah. And that makes sense too, because if the way you have to get some infrastructure up to do your weekend project, let's say, or your startup is first you have to create a Kubernetes cluster, whereas first you just have to install a CLI, and then I think Claude writes Terraform just fine. You say, hey, write me the code to do these certain things, and you're up and going. Like, there's certainly a barrier of entry difference there that's significant. And that is, I think, one of the great strengths of Terraform is it is unreasonably effective. And by that, I mean the ratio of the amount of effort you have to put in to get going with it is huge relative to whatever issues you have when you start scaling, or if you think that there is another model. Like, that is just an amazing ratio of ease of use versus how far you can go with that.
I have some strong opinions about the decisions that Terraform makes for the early adopter, the basic user, because it hides a lot of initial complexity from you to make the tool super easy to use. But I think that speaks to what you're saying is like they made it so easy for someone to get up and running within minutes that once you were in, you were like, I'm in too deep. It's too late.
Like, you're like, all right, I got to copy this .tf state file that I keep on deleting from my directory somewhere, I guess.
You mentioned AI briefly. Like, Claude and other AI tools that are out there. And I'm curious, like, what role do you see AI taking in the world of IaC? Is it going to replace it? Can we just tell Claude, go stand up this infrastructure and hope? Or is it going to be more like Claude writes the Terraform code that then we deploy?
I think it's more the latter.
Hmm.
And at least what I see is that you want a human on one side of the loop on a lot of these decisions. And that
Right.
is either the computer is writing the code and you're reviewing it, or vice versa. I think in general, it's a bit easier and more trustworthy to have a computer write the code because a great feature of Terraform and Tofu is the plan file. And so you can see this is what the code does. Are these the resources I expect? You can review that and you say, yes, that's what I want or what I don't want. And if it's not what you want, then you tell it to try again. But you have, unlike application code, where you might have some weird edge case or something, the plan is what the thing's going to do. So if you don't like the plan, don't do it. If you like the plan, then do it.
The thing that I've been thinking about is with the advent of MCP servers, which now allow LLMs to inspect the actual APIs that are available by parsing through documentation and whatnot. I could, in theory, just have an LLM deploy the infrastructure for me through MCP servers and maybe get something that's fairly reasonably correct. But I don't know how you would maintain that going forward. I think that's my
Yeah.
biggest conundrum with all the AI stuff is like,
Hmm.
great, I got it to make an application for me. How do I maintain that for the next 10 years?
Exactly. That again, going in reasonably effectiveness of Terraform and Tofu, it's like that plan file is so helpful. And bypassing that, I think it's hard to scale when you want something to make changes if you can't see, well, what is the thing that it's going to do?
Malcolm, this has been quite a thought provoking conversation when it comes to IAC. I think we all recognize there's limitations, but there's still a lot of promise there too. And I'm so curious to see what happens in the next few years. Any last thoughts that you have around the whole conversation when it comes to IAC?
Yeah, I think so. For one, when you see a LinkedIn post saying Terraform's dead this year or next, something like that, I think the person who wrote that post hasn't gone out and touched grass in a really long time. So just ignore them. I also think that if you don't actually think IC solves the problem correctly, then you should keep in mind that these things aren't static. Tofu and Terraform are being actively worked on. They are evolving as users come to them with new desires and new usages and all that. Like they will change that. We are working on trying to bridge these as well. Like we recently released something called initial things around this thing called State Graph, where we're trying to bridge the gap of IaC and something more Kubernetes-y like, where you have more of a control plane. Like the people are innovating, people are trying new things. I think that IC is really effective at what it does, and these other things are effective at what they do as well. And I think we're probably gonna end up converging over the next 2 years rather than any one of these necessarily dying off.
Hmm, I like that. I like we'll converge back on a solution that meets everyone.
Yeah.
Hmm.
I also know that you have a book, or Terra Team has a book coming out very soon, an ebook. You want to tell us a little bit about that?
Yep. It's a pretty great book, if I say so myself, about migrating between cloud and on prem. We had a lot of great people contribute to it, give their insights on what worked for them, what didn't. And it's entirely free to grab on our website. I think there'll be a link somewhere in the description. So please check it out.
I know you're on LinkedIn. Is that the best place for people to find your thoughts and ideas?
Yeah, absolutely. I do not touch the other locations on the internet.
Okay. We'll include a link to your LinkedIn profile as
Thank
well.
you.
Malcolm Metalka, thank you so much for being a guest today on Day 2 DevOps.
Thank you so much. It's been an absolute pleasure with both of you.
And virtual high fives to you, dear listener, for tuning in. If you have suggestions for future shows, we'd love to hear them. Hit either of us up on LinkedIn or send some feedback via packetpushers.net/follow-up. You can find me, Ned Bellavance, at nedinthecloud.com and my amazing co-host, Kyler Middleton, blogging over at letsdodevops.com. And we're both terminally active on LinkedIn. Stop by and say hi.
If you've got a way cool cloud product you want to share with our audience of IT professionals, become a Day 2 DevOps sponsor. You'll reach several thousand listeners, all of whom have problems to solve and maybe dollars to spend. Maybe your product fixes their problem. We'll never know unless you tell them about your amazing solution. Find out more at packetpushers.net/sponsorship.
Until next time, just remember that doing DevOps is awesome, and so are you.